Okay, so we only have 3 more units left of this class, and I feel like it went by really quickly. But now we are finally on the arguably torturous unit of this year, and that is series. Many people can agree that series is the most people's least favorite unit just because it's so tedious and annoying, but you gotta do it. And you know what? It's actually kind of fun after a while. I don't know how to say it better than that. Well, there's going to be 2 series units. The first one is basically on tests of converging and diverging series, which I kind of explained 2 units ago. I talked about improper integrals, but I will, of course, reiterate in this video what that means when I say converging and diverging series. And then you learn tons of different tests to find out if a series converges or diverges, and to at least get an approximation or an exact answer if it does converge. Then, next unit, we'll be talking about some more complicated series stuff, including Taylor series and Maclaurin series, talk about Lagrange error, and basically just more advanced series stuff. But this is the introduction to series, so I think it goes saying we should probably start off with what is a series. A series, you may remember from pre-calc or your algebra class, is written in a sigma notation, looks like that. And then on the bottom is what the starting value is, and on the top is what the ending value is. And what a series basically is it's a notation to write out addition of different things of a series. So for example, if you had a series 2, 4, 6, 8, dot dot dot, where they're going up by 2 every time. First off, this actually would be called a sequence because they're just comma after each other, but this is a sequence right here. And every time you're adding 2 to it. So you would, if this you would then could call this 2n, and every place you would just put that number in and you'd get what value. So for example, if you want to know what the 10th term in the sequence would be, it would be 20 because you'd plug in 10 into 2. It's going up by 2 every time. That's how you would do that. A series is a way if you wanted to find out what the addition between all these terms were. Like that. The dot 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 means, like there's a pattern that's going on until, I guess, infinity, like it's not clarified. In this case, to write something like this, this should just be a review. Write, if it's going up by 2 every time, and then we'll write 2n right here. Then down here you would say what the first n value is going to be. Well here, if 2n equals 2, then n equals 1, so the first n value is going to be 1. Then, think about, if I also could have started this off as 0, but if I started this off as 0, I would have to have a plus 2 at the end of it, because then that would compensate. But I'm just going to leave it as the 1. And then, because this is the dot to dot, we say this goes to infinity. That right there would explain this series. So that's what a series is. To jog your memory now, there's series that go to infinity, and then there's series that are finite. Like, for example, if I wanted to just know, and this is a pre-calc topic, but what if I wanted to just do n equals 1 to 3 of 2n? Well, this would just be plug in 1 for n, you get 2, plug in 2 for n, you get 4, plug in 3 for n, which is the top one, you get 6, and therefore the answer would be 12. Okay, well, unfortunately, what I just taught you is way, 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 way too simplistic for this class, obviously. You're in Calc BC, so we're going to be doing things a little differently. Now, if you remember from your algebra class, your pre-calc class, there are 2 types of series. There is an arithmetic series and there is a geometric series. An arithmetic series is what I just explained to you, and it's something algebraic, like 2n. N plus 5, like something algebraic. But geometric series is when a certain value is being taken to the nth power. An example of a geometric series would be 2, 4, 8, 16, dot dot dot. Because in this series, which I'm going to write out, I keep doing these as commas, I don't know why, but a series is when they're being added. So, to explain this, it would just be 2 to the n, and if it's some value to an n, that's a geometric series. So that brings us to our first test for calculus geometric series. So see, that's not too hard. In calc, most of the time we'll be talking about values going to infinity, starting from usually either 0 or 1. We'll start this one from 0. And let's say right here that we have something like 1/2 to the n. Now, in calculus, you're going to be asked, does this converge or diverge? Now, convergence means that when this goes to infinity, you're going to be adding smaller and smaller and smaller numbers, and eventually these numbers are going to be so infinitely small that they're basically insignificant, and your sum will just meet at a certain point. So, for example, on this one, you have 1/2 plus 1/4 plus 1/8 plus 1/16. As you can see, these are getting smaller and smaller and smaller. And the idea is that eventually it's going to be 1 over something so insignificant, like, I guess, infinity. But I don't want to say that because not every time it's 1 over something you're going to get infinity, which is basically 0. And it'll be adding such small, small numbers that it won't even matter anymore what you're adding, I guess. That makes sense. So that would be converging. Diverging would be if it's just going to go to infinity. So for a geometric series, I think you learned this in pre-calc, but a geometric series is going to diverge if whatever in here is being taken to the end. And by the way, it's also going to be taken to like the n minus 1. If you don't know, n minus 1 would be the same thing. Actually, I should say n plus 1 to make this easier to understand. N plus 1 would be the same thing as 1/2 times 1/2 to the n. So yes, just like integrals, you can actually pull constants out of series. So if this was the case, then you could actually pull that out of the series, but that's not the case here, so I don't want to confuse you. Basically, to know if a geometric series converges or diverges, you have to see if the value being taken to the nth power is between -1 and 1. Because if it's over -1, then, like for example, if you had 2 to the n, well then the number's going to get bigger every time. If you're adding a bigger and bigger and bigger number, it's never going to get smaller and smaller and then converge to a number, so that would be divergent. And same thing for in the negative direction too. So in this case, this would converge because it's 1/2. Now here's where it starts getting annoying. To write this answer, if the question said, does this series converge or diverge, you would say series converges, and then you have to say what type of test you're using. So in this unit, you're going to be learning different tests that you're going to be using to test whether or not a series converges or diverges. This one's called the geometric series test. So you would say it's the geometric series, and then you have to say how you know that this geometric series converges. So you have to say what r is. R is the value that's inside here. So you'd say r equals 1/2. Every time you want to answer a question, you have to write all three of those things. That whether it diverges or converges, what test you use, and how you know that the test. A lot of times, on some later tests, you can just say what the name of the test is, and you'll be fine. But in this one, for example, you need to say what r is for this to make sense. And that is basic geometric series. I also want to say one more thing. I know this is a long video. I didn't mean for it to be this long. I don't know how I got this long. But let's just also remember from pre-calc that the sum to infinity of a geometric series is a sub 1 over 1 minus r. R, as we just said, is the value that's being taken to the end, so that'd be like 1/2 to the end, then r is this value. A sub 1 would be the first term, so that would be, in this case, when I went from 0 to infinity, that would be 1, because it'd be 1/2 to the 0th power. So then the geometric sum would be a sub 1, which is 1, over 1 minus r, which is just 1/2, and therefore 2. That means that if you add 1/2 plus 1/4 plus 1/8 plus 1/16 onto infinity, you're eventually going to get 2. What a round number. It's funny, but yeah, geometric series.